Hi, this is Michael Pfeifer. Welcome to another episode of the Metal Conversations podcast. In this episode, I'll talk about a heat treatment process that's used with cold work metals. The annealing process used with cold work metal is called a recrystallization anneal. It's helpful to refer to the complete name recrystallization anneal because there are some different annealing processes for different metals that are not only used with cold work metals, and so by saying recrystallization anneal, we understand that this annealing process applies specifically to cold work metals, which is very helpful for making sure that we're communicating the right ideas when we're talking with people about a process or trying to make a decision about something to do with the metals or trying to solve a problem with a metal when it doesn't have the right properties. But in any case, the recrystallization anneal is used with cold work metals. So with cold work metals, during the cold working process, the metals are strain hardened, which means their strength increases as the metal is cold worked. And the cold working can be with cold rolling sheet or plate, or drawing wire or tubing or rod to reduce its thickness or reduce the diameter, or reduce the wall thickness of tubing. And a material can only be cold worked so much before it cracks. So during cold working, it's important for people to know how much material can be cold worked before it will crack, before it is cold worked too much. Annealing is used with cold worked metals when we want to take the metal that's been cold worked, that's been strengthened due to cold working, and reduce its strength back to the lowest possible strength, and also improve the ductility of the metal. So during cold working, as the strength increases, the ductility decreases. If we want a metal that has lower strength and has more ductility, then the metal has to be put through a recrystallization anneal. During a recrystallization anneal, the metal is heated up to a certain temperature, and the temperature depends on the metal and the amount of cold working. At this temperature, changes occur inside of the metal. New grains form and grow inside of the metal, and those new grains replace the cold work grains. And as a result, there are other changes in the metal that result in a reduction in the metal's strength and an increase in its ductility. In the annealed condition, the metal will have the lowest strength for that metal and the highest ductility for that metal. The reason that lower strength and better ductility is needed is because someone might be taking that metal and then wanting to form a component out of it. And if the metal is strong but has low ductility, then it will be difficult to fabricate a component out of that material. So annealing enables the metal to be formed into a component. Another reason for doing the annealing is that at the mill where they're making the metal, they might want to continue to reduce the thickness of the metal or modify the tubing shape, and they've cold worked it to a point where they can't cold work the metal anymore, and the metal has to be annealed in order to be able to continue to cold work the metal. So there are a couple different reasons for using the recrystallization anneal. So that explanation will hopefully help you understand the terminology and the purpose for using a recrystallization anneal. The other thing I want to talk about is the general use of the term annealing. As I mentioned earlier, annealing refers to heat treatments that reduce metal's strength and increase its ductility and may cause some other changes, but the strength and ductility are two important parts of annealing. For different metals, there might be a couple of different annealing processes depending on the changes that we want to have in the metals. Referring specifically to recrystallization anneal is helpful for understanding that we're specifically using this heat treatment with cold work metals to get certain changes, and that we don't confuse it with other heat treatments that might be used with that same metal. The other problem that I've seen is that people use the term annealing with other heat treatments that do not result in reduction in metal strength and improvement in ductility. That can lead to confusion when communicating with other people about a heat treatment that's necessary for a metal or for a component and the desired outcome. For example, people will sometimes use the term anneal when they're really referring to stress relief. And stress relief is not an anneal. The changes that occur in a metal with stress relief are totally different than the changes that occur with annealing. Another place where it's used incorrectly is with precipitation strength in metals. So with precipitation strength in metals, there are a series of heat treatments required to get the desired strength in the metal after the heat treatments. The first heat treatment step of the precipitation strengthening process is called a solution treatment, but sometimes people will refer to a solution anneal, or they might just use the term anneal, and that really means something totally different than solution treatment. This is another example where understanding the terminology and where it's applied is important for properly communicating what you want and what's expected, or what has been done to a metal. And then there are some other applications or situations where people might use the term annealing to refer to something that is really not annealing, but they really think it's something else. So understanding what annealing is and the objectives of annealing and the changes that occur inside of the metal during annealing is important for properly communicating the process that we want to have done or that has been done to a metal, and communicating the expected results of that process. When people use the right terminology, then we're able to effectively communicate with each other and make good decisions and solve problems quickly. And then there's a problem when people don't use the terminology correctly. That's when problems occur. We get miscommunications. Decisions might take longer to make, or problems might take longer to solve, or it can also create problems where someone refers to an annealing process. They use the term annealing, and the other person thinks that they understand, and it turns out that both people had different definitions for the term, and maybe both were wrong, or maybe just one person was wrong. But in any case, a decision was made and something was done that might not get the desired outcome because of the miscommunication. There are ways for people to learn more. There's a lot of information on the internet. If you go to the internet and look on different web pages, like Wikipedia even has information. There are a lot of websites that have information. If you're going to use that as a resource, make sure that you look at a lot of different websites and make sure that the information corroborates with each other and that it's consistent from one site to the next. And if there are inconsistencies, try to understand where the inconsistencies lie. Also go to handbooks and books, maybe read a book on metallurgy that talks about different annealing processes, or a book on heat treatment that talks about different annealing processes. And finally, take some courses and learn and get information about the annealing processes. This will be beneficial to you in terms of reducing headaches, being able to make decisions faster. You'll be more productive, and you'll just be more knowledgeable, which will be valuable to you. And if you're a business leader, it's important to you to have your employees understand the terminology for the things that they're working with, so that they can properly communicate with each other, communicate with suppliers, and communicate with customers, so that you make a better product and better decisions are made faster, and when problems arise, they are solved faster. Finally, we have a YouTube video that is a companion piece to this, as well as an article on our website. Go to our YouTube channel, and you can subscribe to our channel to get notices when we release new videos. Thanks for listening. Good luck with your metals. Bye.